You got it. Okay, so here's a question, and the reason it don't have any directions or anything is because I'm going to make up some questions, and they're going to come from 4.3 and 4.4. But let's reiterate 4.3 and 4.4. I'll go over to the next page. And I wrote, remember in your notes, I divided it into two. In 4.3, I told you was the additive law. Which circled around the word what? Or. And when you see the word or in your question, that means you're going to use the additive law. And I told you to highlight or put in red or important. I told you to always subtract the what? Always subtract the overlap. Okay? So that was the three things we talked about 4.3. It's the additive law. It centralizes around the word or, and whenever you use the additive law, make sure that you always subtract the overlap. All right? Now with 4.4, and again, I'm sorry, I thought I covered the material, but evidently I just wrote it down. That's the multiplicative law. Which is centralized around the word and. And what you have to remember about the multiplicative law is with replacement or without replacement. And that's the things you have to remember about the multiplicative law. I was telling the rest of the class I forgot to go over 4.4. I wrote it down, but I didn't go over it, so that's why I'm going over it today. I think we went over 4.3, but I wrote down 4.4, but we didn't cover it. With replacement, one of them is called independent, one of them is called dependent. I always forget which one it's called. I don't usually go by that. You have to look in the book and see. With replacement, usually, okay, with replacement, if you replace, let's say you draw a number out of a hat and you replace it, then nothing's affected. The numbers are not affected. Why is the numbers not affected? Because you're putting the slip of paper back what? Back in the hat. All right, so if you got 30 names in the hat, and you reach in and you pick one of the names, write it down, and put it back, how many numbers are still in the hat? 30. Okay, so nothing's changed. But without replacement, that's when the numbers are affected. Let's say that all your names are in the hat, and there's like 10 people in here. There's 10 names in the hat. And I take out one name, and I put it in my pocket. Then what's the chances of you getting picked in the next one? One less. Yeah, exactly. It'd be 1 out of 9 instead of 1 out of 10. So the numbers have changed. 1/9 is not equal to 1/10. So that's, now, the one thing I would like to tell you about this is, does it matter when you get up to large numbers? No. Doesn't matter which one you use, because you come out with the same answer. Doesn't matter with large numbers. Now, a lot of people say, well, Hubert, how do you know which numbers are large? I tell students 3 digits. And you'll see, we'll have a couple of questions, and you'll see what I'm talking about. The with replacement, that's when you're going to be dealing with just exponents. So it says, what is the probability of drawing 5, blah, blah, blah. Then it'd be whatever the numbers are to the 5th power, because you're picking 5. All right? If it is without replacement, then it's going to be exponent minus 1. Because each time you pick one and put in your pocket, what happens? The pot changes from 10 to what? 9. You got a minus 1 each time, and that exponent is effective. So with replacement, it's just going to be the exponent. Without replacement, it's going to be the exponent minus 1. All right? Now, that's the difference between the two sections. Most of the time, these will both be in reference to a table. Okay, both of them will be given in terms of a table. And remember, I told you on the additive law, don't think too much about the table. They just use your highlight and go across, and then wherever it overlaps, you subtract. Sometimes they don't give you a table. So what does that mean you need to make? A table. All right? So if they don't give you a table, you need to create a table. So if they don't give you a table, then you need to make one. And we'll look at that also. So, going back to the problem I had written on the board. This problem right here, you can write it down. I just plucked one out of a book or one of your problems, and the reason it doesn't have any directions or any kind of, because I'm going to make up problems as I go. I can make up problems in 4.3 and 4.4 out of this table. It just depends on what I ask you. So give everybody a minute to write those down. I don't know. I get 206. Do you get? I don't think that's right. No, it can't be. That's 50 and 40. That's 90. 50 and 40 is 90, plus 5 is 95, that's 100, 108, 118, 120. Somebody add those up and see if you get 120.
Was the top number all of them?
All of them. $108, what'd I say? 120. So that, you know, and we'll write that to the side, you know your denominator is going to be basically 120. Because that's the total of whether you use the multiplicative law or whether you use the additive law. At least one of them is going to start with, you're going to have a denominator of 120 because that's your total. Now let's say that I ask you, what is the probability of having RH positive or O blood? Well, what does the word or mean? It means additive law. So put you a little addition thing there. And that means you're going to use the additive law. So to take your handy dandy highlighter and RH positive goes across there, and O goes there. So that's going to be equal to 52, and we'll write this in yellow. I know it's going to be hard to see, but I'll need to do it for a reason. So 52 plus 43 plus 8 plus 5, and for those people at home, I know it's hard to see that, but it's It's harder to see on video, but it's not on this screen capture. You can actually see it. And then we're going to add in green, we're going to add 52 plus what? 6, and put that in parentheses. And then we're going to, I'm going to circle this 52 right here because that represents what? The overlap. And I'm just going to do that in black because that is an overlap. Minus 52 all over 120. So you could actually cancel out these 52s right here, or you could cancel out this 52 with this one. I got a degree in everything. I know you can do that, all right? But I don't show that because if I showed you that at the beginning, you'd go, wow. So that's why I teach it like I teach it. So I'm going to go ahead and just take this one out with this one. Is that okay with y'all? And now I'm going to add everything up. And that's going to be 52 plus 43 plus 8 plus 5. Sorry. Sometimes this board just doesn't work with me. Plus 8 plus 5 plus 6 all over 120. Okay? We know that's 95. 95 and 5 is 100. 114 over 120. Now we can reduce that because we don't want to depend on our calculator. So let's reduce it down to, well, we know that's 60. And that would be what? 57 and a half or 57?
It ends up 19
Okay, that's good enough for me. 19 over 20. And 19 over 20 is right there at 1. Because when you have a fraction and there's 1 between the difference, it's close to 1. But what does it come out to be? Somebody, what do you get? What's 19 divided by 20? How much? 0.95. So your probability of pulling one of these blood types is 0.95. And 57.5 should be that, but you said 20, so that means 60 is going to be probably. I'm not going to worry about it. Anyway, that's an additive law. Now let's try another additive law. And then we'll move on to the multiplicative law. Because I had a couple of people say, we go on to the multiplicative law. I'm like, I thought we did. But y'all didn't say anything, so it's y'all's fault. Alright, so I want to know the probability of O or B. So you find that one. O type or B type.
So if it's or, then we have to use additive, and if it's and, then we have to
If it's and, yeah.
then we have to use multiplicative.
If it's or and. If it's or, it's additive law. If it's and, it's multiplicative. Simple as that. So you take your handy dandy highlighter and you erase all the other ones. And you take your handy dandy highlighter. I'll try to use different colors that show up better. Let's use our purple is O. So there's O. And our blue will make B. So blue or purple, we're going to have 52 plus 6. And then we're going to add 8 plus 1. But what about the overlap, Hubert? If it ain't broke, don't fix it. Is there an overlap? No. So if there's not an overlap, you don't worry about it. Over what? 120. So 52 plus 8 is 60, 67. And somebody give me that decimal. 0.56. So if there's an overlap, if there's an overlap, you subtract it. If there's not an overlap, then you don't reinvent the wheel. That's why I show the overlap. That's why I teach the overlap. Because in the previous problem, there was an overlap, you subtract it. If there's not an overlap, you don't worry about it. Capiche? Everybody feel good about themselves? Okay, now the multiplicative law. Now we're going to cover a couple more, because I've covered additive law with you. I think I've covered a couple additive laws. And I just did a couple more additive laws. But after we do a couple of multiplicative laws, I'm going to pull a couple of homework problems up, especially the ones y'all sent me, because since I didn't cover it, I'll cover it. All right, so I'm going to do the probability of I don't want to do the probability. Let's do the probability of picking O and O. In other words, you're going to pick, and this is without replacement. And you're going to pick O and O. So you're going to pick two, you're going to draw 2 times. And you want to know what is the probability of both of those times you picking an O type blood type. Now, without replacement usually is used more than with replacement until you get to the big numbers. And when you get above 3 digits, it doesn't matter. And we're going to see that in just a minute. But most of the time, when you have small numbers, or these small numbers, yes. Is 206 a small number? Yes. Okay, compared to this, yes. These numbers are small. So 9 times out of 10, if you've got small numbers, the directions are going to tell you what? Without replacement. Also, when you're talking about bodies or votes, like drunk drivers, you're not going to be able to count a dead body, what? Twice. All right? Usually with bodies and votes, there's a political question in there about senators voting. You can't vote twice. All right? So usually with votes and bodies, you're going to be without replacement because you can't go, okay, this body, he's a drunken driver, he died because of this, and then go, okay, put him back in the pile. You know, you can't do that because once you die, you die. All right? There's no using the body twice. All right? So let's think about the whole group is what? 200 what? 206, right? So that's going to be our denominator. So 206 here. How many is O?
Where did that come from? That's 120.
I'm sorry. I keep thinking I got a problem in my head somewhere. I keep thinking 206. I said that at the beginning of the problem, didn't I? What is it? One what?
120.
I'm sorry, what?
120.
120. Thank you. All this is equal to 120. So that's our denominator. Okay? Now how many are O? 50 what? 58. So your first drawing is going to be 58 over what? 120. Your second draw is going to be out of what? 57 out of what? 119. There you go. And now you take those two and you multiply them together. So somebody, just give me two digits. What's 58 over 120? 0.48. And 57 over 119.
0.48.
And multiply those two together, what do you get? 0.23. So you got a 23% chance, or a 0.23 probability. If you pick two of these out of the hat, they're all written down on, then you'll have two simultaneously that are O positive, or O type. And that's 0.23 probability.
So you can just put it like that, you don't have to turn it back into a fraction.
No, most of your probabilities are going to be in decimal form. That's one way of doing it. Now, what if they say with replacement? Yes, sir.
So you said when you were talking about probabilities, the decimal means the chances, so is that the difference between the two?
Yeah, pretty much. It doesn't make any difference to me. But some teachers that eat, drink, and sleep statistics, they will have fits. If you say, you got a 23% probability, they'll have a cow. It's 0.23 probability or a 23% chance.
So the question actually chances.
Yeah. It's not a big deal. But some teachers will have cardio infarction, something. They'll go into hysterics. Kind of like a physics teacher when you say speed and velocity is the same thing. They go into a conniption. Same thing. I don't care. Because we don't need to worry about that anymore, okay? All I need you to worry about is if you can get the answer, okay? If we were in a theoretical statistics class, then we would talk about it. All right.
You asked if it was with replacement, it would be the same answer.
With replacement, I was going to show you. Probability of 0 and, not 0, O. And that's going to be 58 over 120 raised to the second power. Now do that in your head. Do that in your calculator. Okay, a while ago I said it's not exponent minus 1, it's n minus 1. I'm sorry. When I wrote exponent minus 1 over there, it's n minus 1. N and then n minus 1. That's what I meant, not the exponent minus 1. So, what do you get? Point what? Just give me two decimals. 58 divided by 120 and then raise it to the second power.
I got 100.
Well, it came out to be the same this time. But it won't do that in all questions. Sometimes, most of the time, they're going to tell you to go to 3 digits. 3 decimal places. And you'll see in a problem that we do, because I made this problem up. I didn't make this problem up, but I don't know if this was additive law or multiplicative law, so I don't know what it was formulated for. But most of the time, all your answers are going to be 3 decimal places. And you will see, when we do it, you'll see the difference when we do the CD problem especially. Okay? Let's go to the CD problem, because that's the one I like to do anyway. It's the one I like to put on the test. So,
So you said about more than 120?
huh?
When it's without?
Right here.
Yeah, I'm saying.
Without replacement. That means, remember, you're picking a name and you're putting it where? In your pocket, not back in the pot. So when you take it and put it in your pocket, you've got to what? Subtract it. That's why. Because you're not picking out of the same group. You're picking out of a smaller group. Let's see, is this 120? Yeah. 4.4, yeah. Where's the CD question? There's that problem I got it from. But I don't want that one. I want the CD question. Okay, I know they have a CD question. I saw it. Let me just keep looking. I guess it's in 10 and below. It's a conspiracy. There it is. All right, y'all look at that problem, write it down. You don't have to write it down word for word. Just get the gist of it. Because it is a homework question and a test question. I would put it, we're going to do a couple of these because there'll be a couple on the test probably. With one method of procedure called acceptance sampling, a sample of items is randomly selected without replacement. Without replacement. And the entire batch is accepted if every item in the sample is good. All right, what does that mean, Hubert? Well, let's say you work at let's say Cryovac. All right, Cryovac in Seneca, I think they make plastic for CDs. And I don't know if they make the CDs or if they make the plastic that goes around them. The whole point is, let's say that they make the CDs. And let's say that they make, when they make a box of CDs, and a box is like a crate, let's say that there's 5,000 CDs in that crate. In past studies, they know that 15 is going to be bad. All right? So what they do is they pick 15 out of each box that they manufacture. And if every one of those CDs are good, meaning that you can record on it or whatever, then the whole shipment goes to Walmart or Target. And you let them deal with returns. In other words, Walmart, go to Walmart, you return it, you get another CD. All right? That means that the company is putting out a good what? Batch of product. What if one of those 15 turns out to be bad? Does it go to Walmart? No. It goes back to where the problem is. They find the problem and then they go and what part of the company is making this defect and they fix it until they get 15 back again. And that's called quality assurance. All right? So, it says a company has just manufactured 879 CDs, and 237 are defective. All right? They base that 237 on a percentage, like I based it 15. All right?
Question.
Yes.
Like if you're taking CDs out and you're picking like good ones, then why wouldn't you subtract the top ones?
Well, you are. You're going to. But you got to set it up first. And so the problem with this problem is people don't know how to set it up. All right? So, let's go ahead and finish writing down the problem. And it says, and 237 are defective. If 3 of these, so in each box you're going to pick out 3 CDs. Each one of the 3 has to be what? Good in order for it to go to Walmart or Target. If one of them's bad, then they go back to wherever they're being made. And somebody gets fussed at. Or a problem with the machine, or somebody's not turning them over, or something. Something is happening to make one of those 3 bad. And if one of those 3 are bad, then the whole batch is probably bad. So, what I tell students to do, it's very simple, is draw a big old box. Because that box represents the box of CDs. But you got to draw it big enough to where you can draw numbers in it. Okay? So what I tell students to do is take your handy dandy whiteboard and make it transparent first, and then make a big old box. And you know that in this box there's 879 CDs. Now, you know by percentages in the past for the company that a certain percentage, in this case it comes out 237, are defective. 237 are bad. And how many are good? It's a compliment. Huh? 642. So 642 are good. Now, if you don't know how I got that, it's the complement. 237 subtracted from 879 is 642. And that's how you set the problem up. Now, the problem says, what is the probability, okay, if 3 of these are randomly selected, 3 of these CDs, 1, 2, 3, are randomly selected, what is the probability that all 3 are what? Good. Because if all 3 are good, the whole batch will be what? Accepted. So you could rewrite this and say, if 3 of the CDs are randomly selected, what is the probability that all 3 are good? And if all 3 are good, the entire batch will be what? That's what they really should say. Now it says without what? So that means without replacement means that you have to subtract 1, right? So 642 over 879 times what? 641 over 878 times over. Okay, why do I stop there? Yes. Here's the first one you pick, here's the second one you pick, and here's the what? Third one. It says 3 CDs. And you're testing to see if all of them are what? Good. That's why you're using 642. You're not going to use this guy unless you want to test to see if any one of all 3 of them is bad. You want to check this one. Now, let me ask you something. Are all 3 of these, are all the numerators and denominators, are all of them 3 digits?
Yes.
And they're pretty high. So I'm going to go down here, and I'm going to say 642 over 879 raised to the what? Third power. Let's see what that is. Round to 3 digits. So somebody do this first top. I'm not going to go through each one. Somebody multiply these 3 fractions together and give me 3 digits. Point blah blah blah. What is it? 0.389. Everybody else get that? I just want to make sure I don't want y'all to set me up look like a loser up here. Everybody get 0.389. Okay? If everybody got 0.389, take 642 and divide by 879 and raise it to the third power. See what you get. Raise it to 3 digits.
0.390.
Okay, it's not supposed to do that. Okay, it's the same thing, yeah. It's the same thing, because both of them are 390. The main thing is that you see that if you got very high 3-digit numbers or above, does it matter which way you do it? No. It says round to 3 decimal places, so I assumed that this was 389 something.
It was 3896.
And what was this one?
3891.
1? Okay. 0.3896. So you might need to go with this one. I mean, I'm just showing you. Most of the time they just ask for 3 digits, and most of the time, I've never seen one like this. This one usually these high numbers, usually they don't make that much of a difference. They may have a tolerance in here though. Let's go ahead and type in 3. I want to type in 390 and see if it'll take it. If it says it's the right answer, then that means that it's got a tolerance in there. 0.390. Yeah, they got a tolerance in there, 0.001 or something like that. Okay? What does that thing say? I hate these questions. That's why we change in books, because of these stupid questions. Does the result in A suggest that the entire batch consists of good CDs? Well, 39. What is the probability that the whole batch is accepted? 0.39 probability or 39% chance. What would you say? Well, it's not half, is it? So I would say, does it suggest the entire batch are good? I would say no. Okay, because I don't know what the, let's see, because the sample will always consist of good CDs. No, because only a probability of 1. Yeah, I would say this one. Okay? Even 0.5 would be better than 0.39 because that way you have a 50-50 shot. So anything below 0.5, well, technically anything below 1 is not good. Capiche? All right, let's do another one, and I'm going to let y'all. All right? Do that one. Blow it up a little bit for you. And then we'll look at some homework questions that people have sent in. So we've got a batch of CDs here, and we know that 852 are in there, and out of 852, 214 are bad. So if 214 are bad, how many are good? I'm sorry, what? 638. And they want to know if 3, then that would be 638, 637, 636, and 852. $851. And $850. And multiply. And somebody give me 4 digits, what that one comes out to be. 4194. Now that is the answer. And of course that would be 0.419. So let's go ahead so you can see these are fairly high 3-digit numbers. 638 divided by 852. And let's say with replacement. And somebody tell me 4 digits what you get there.
0.4198.
So you see there's not much of a difference between the two. And they give you a 0.001 tolerance in the question, so I think you'll be okay. But just so you'll know, without replacement, you better hang with that just in case. But you can always check to see if you're doing that right by doing this, and your numbers will be what? Real close. Let's say you do this one and come out with 0.3841, and you do this one and come out with 0.4198, you know something is what? Wrong, and you need to redo the first one. Okay? All right, let's look at some of the homework problems that were sent in. Since I didn't cover it, I apologize for that. I guess when I wrote it on the board, I thought I covered it. I guess I just didn't have a brain bubble. I don't know. All right, let's see. got one right here. This is 4.4. 4.4 5/1. 4.4 5/1. For the given pair of events A and B, complete parts A and B below. When a page is randomly selected and ripped from a 19-page document and destroyed, it is page 15.
So 1 out of 19.
Yeah, but I don't understand the question. I'm trying to.
Like it said, yeah,
Okay.
the probability of it being a page 15.
Okay. All right. And B, when a different page is randomly selected and ripped from the document, it is page 5. Determine whether events A and B are independent or dependent. If two events are technically independent, but they can be treated as they are independent according to the 5% guidelines, consider them to be independent. This is not a test question. Find the probability of A and B. Probability that events A and B both occur. Well, you see the and, you know it's multiplicative, right? All right, but in multiplicative, we have to discern whether it's with or without replacement. So let's look and see.
Because you tear it out, you can't put it back.
Exactly. So it's without replacement. When a page is randomly selected and ripped from a 19-page document, so we know it's the denominator is 19, and destroyed, find the probability that it is page 15. Well, that's 1 out of what? 1 out of 19 is what I would think that would, I don't know. Y'all tell me if that's what they did. Okay, because that's all you can do on the first one. Now, when a different page is randomly selected, well, you absolutely know that this, if they haven't given you any other information, this is going to come out of 18 pages. All right, and it says rip for page 5. So that'd be 1 out of 18. All right. Now, what they're saying right here, if two events are technically dependent, but can be treated as if they are independent according to the 5% guideline, consider them to be independent. Now, what that means is the difference between the two is mu minus old over old. Okay? If that is less than 0.05, then it's not that big of a difference. This is the first time I've seen this question. Okay? I didn't know it was on there. All right, so mu is what? B is 18. So 18 minus 19 over 19. Somebody do that for me. I don't care about the sign. All I care about is the percentage.
Negative
0.05. It's right at 5%. So chances are they're going to make it. They're going to say as if they are independent according to the 5%. Consider them to be independent. Well, since it's right at 5, they're probably going to leave it to be independent. So I don't know. The two events are dependent because I don't know exactly what they're asking here. Choose answer.
But since it's like 0.052.
Oh, A, is this 0.052?
No, that
Oh, this?
yeah.
Okay, what is it? Point what?
0.052.
052? So that's 5.2%. So it's above 5%. So there is a difference. There is a difference. So we would leave it. Okay, so choose the answer correct below. When a page is randomly selected, that'd be 1 out of 19.
So you just do 119 times 118.
No, the question is not asking for a number. The question is asking,
It'd be they're dependent on each other.
yeah, because you pulled one out of the other. I know that, but I'm trying to figure out what the question is asking. The two events are dependent because the occurrence of one does not affect. Well, that's bullcrap. Why is this not right? Because it is affected. So does not affect is not right. Okay? The two events are dependent because the occurrence of one affects the probability of the occurrence of what? That's a possibility. Let's read the last one just in case. The two events are independent because the 5% guideline indicates that they should be treated as independent. Well, the 5% guideline, we're over what? 5%. So I think it's C. Okay, because this is over probability. Please work with me. Probability is over 5%. And is that probably, what if it was 0.042? If it was 0.042, then it would be independent, which would throw you either in this problem or it would put it up here. One of these. Did they ask something else? Okay, probability. Then you take, since it is, you take 1 over 19 times what? 1 over 18? Somebody multiply that out. What do you get? 0.0029 should be your probability, or B. I don't know, but C is what I would pick. Never seen this problem before. Must be new. Well, we got that one right. It says 4 decimal places, 0.0029. It's a miracle. And that's how you do that one. Okay? Say again. You got it? Y'all feel good about yourself? All right, let's do a nerd. Let's find one that somebody else sent in. Where's my? There we go. 4.3 19/10. 4.3 19/10. Okay. I'll blow it up for you.
Can you just like make it a similar one?
Huh? Yeah, we'll do this one and then we'll do a similar one. The following data summarizes results. Okay, 952. What is 952? Denominator. Okay? Were caused by accidents, and one of the pedestrian's deaths is randomly selected. Find the probability that the pedestrian was intoxicated and the driver was intoxicated. Every time I just laugh when I'm sorry, but the pedestrian was intoxicated and the driver was intoxicated. What is the probability of a drunk driver hitting a drunk walker? I mean, if you think about it, it's funny. Oh, no, you're going this way. I mean, I just laugh every time I think about that. All right, so what does this word mean? Okay, I'm not going to blow up anymore. That's why I give it to Vanna. I keep staying doing that. All right, so take our handy dandy highlighter because of the or. Or means additive law. Well, I'm getting tired of fooling with it. All right, so that's additive law. So I'm going to take my handy dandy highlighter and I'm going to highlight one in purple. Well, magenta. Okay, the pedestrian was intoxicated. And the what? Driver was intoxicated. So now I'm going to write everything in magenta. And so 76. $76 plus 83, and I'll change blue, plus, dang, I do the fast acronyms. Sorry, let me change it. These wrong colors. Trying to do colors for y'all, and I can't even read them myself. 76 plus 83, and magenta is 76 plus 231, and then we're going to subtract the what? And the overlap is 76. And all that is over the denominator, which is 952. Now the 76 will cancel with that one, or even cancel with this one. And that'll leave 231. Well, I don't want to use my calculator because I don't want to depend on it, because later I might be a cashier and I want to make change and I want to be able to do that. So 220 plus 80 is what? 8, huh? Say it again? There, thank you. So that's 300 plus 3 and what, 11 here? So 3 and 11 is what, 14? So that'd be 314. And then dang old 390. Dang old, what's this 6 cents for? You ever had one of them cashiers? If you're one, please don't raise your hand because that shows me you shouldn't be running the cash register. All right, 390 over, well, 3, that's 400 over 1,000. 400 over 1,000. Dang old 10 left over, dang old 4 tenths. It's going to be around 0.4. What do you get?
0.41.
It's a miracle. 0.4 what? And I did it without a calculator and got 0.4. Your brain works. I have to tell that to every one of my students, because there are some students that believe they can be on the silent calculator drill team in high school and be successful. And you have to use your brain. Okay? All right, similar exercise. Some of y'all have no idea what I mean by the silent calculator drill team. It's people that can twirl calculators on their fingers like a basketball. Those people are dangerous. All right, take off. If you can't do it, then consider yourself a disappointment. And you should quit school and live in a ditch, live in a box overlooking a ditch. Student just emailed me, I can't find 4.4. Just hold on. All right, so this one, what is it? Well, it's the additive law, Hubert. That's right. So we're going to do pedestrian was intoxicated. That's in blue. And in magenta, driver was intoxicated. So in blue, we're going to have 65 plus 262. And in magenta, we're going to have 65 plus 85. And what's the overlap?
65.
Minus 65. And that minus 65 will cancel that 65. And all of this is over whatever the total is, 942. And let's see. We could say these two guys right here, 60 plus 60 is what? 320, so that's 327, right? So 327, 320 plus 85 is what? Plus 80, 320 plus 80 is 300. So that'd be 307. Somebody help me out. Is it 407? Thank you. 407 over 942. Well, that's going to be 400 over 900. 4 over 9, which that means it's going to be 4 over 8 would be half. So this is probably going to be 0.4 something. What is it? 0.4 what?
3.7.
0.4 what?
3.7.
So the answer there is 0.437. There's 2 more additive rules right there. So you got about 6 additive rules in your notebook. Let's check it so we can feel good about ourselves, so we won't have to put smokestacks on our truck. There we go. Everybody ready to wear pink shirts now? I think that's it. Nope, here's one. 4.3, 1910. 4.3, 1910. Just like the one we just did, we'll go through it right quick. Or, additive, blue, pedestrian intoxicated, and driver intoxicated. Blue is 53. Stylus, I pick it up every single time. So I think you just press that. 53 plus 268. Magenta is 53 plus 61. And what's overlap is 53, and of course that 53 cancels that 53. And we have a denominator of 948. We could do 270 right here. 270 plus 50. And add 1. So what's 270 plus 50? 3 what? 270 plus 50? 320? 321? Somebody check this mirror. Okay, y'all really need a calculator for this. 321 plus 61. 382 over what? I say around 0.33 somewhere. What is it?
0.403.
I should have done 4. I'm sorry. I should have done 400 over 900. That's what I should have done. I'm sorry, I forgot that was closer to 400. Forget that. What'll it come out to be?
0.403.
0.403. And you check it. So you can feel good about yourself. So you don't have to put on too much makeup and look like an Oompa Loompa. You ever seen one of those? Orange face, white neck. All right. I don't get any reaction out of y'all. I should give up. Like talking to a dead person. I'm talking to an intoxicated driver and an intoxicated pedestrian. All right. I think that's all my questions. Yeah, because that's that. Yeah, I think that's it. There's a 7 point. No, that's so the. Okay, so we're done there. All right, so let's pull out a. We did the 4.4, did we not? No, we didn't. Let's see. I thought she sent a 4.4 question. Okay, I guess she didn't. Oh, she did. 4.4. I hate these emails. There it is. I hate these emails because you can't find what you're looking for. All right, here we go. We got 4.4. I lost it. Where is it? Let me move this over. She doesn't have it on her. It's 4.4 number 1, but it doesn't have the thing over it. I don't know why. 4.4 number 1. I think we've already done one like this, haven't we? Oh God, yeah. That thing's awful. That is not a test question. Okay? I know, but it's not a test question. I do not like that one. I would not put that one on a test. Let's go to the 4.4 and let's see if I can pick out one more that might be on the test, that I would put on the test. Yeah, but those tables, we can. Go ahead and do that one. It says the data in the table summarizes results from 163 pedestrian deaths that were caused by accidents. If 2 different deaths are randomly selected, in other words, you reach into the hat twice, okay, without replacement, find the probability that they both involved intoxicated what? So intoxicated drivers. Now be careful here. Remember, how many people are in the hat? Huh? Okay. Freeze it for a second. Let me take the roll, please, while y'all working. Vanna. Bottom right corner. Thank you. And today, let's see, attendance, faculty, attendance, 120. Nope, that's the wrong class. 120, 12. Thursday. All right. Remy's here, Bright's here, Brock is here, Cowart is here, Dyer is here, Jones is here, Joshi is here, Long is here, Oyana's here, Putman, I don't remember seeing Putman. She was here the other day. Richardson, that's her. Richardson is here and Slinger is here. Is that Putnam? Oh, that's loser. Oh, I'm sorry, Mr. Bright. Okay. So only one person missing today. Yay! All right, go ahead and hit unfreeze. I kind of messed it up, so there we go. All right, y'all with me? So 69, right? So 69 divided by 163 times what? 8 times what? Goes over. The first one is going to be 69 over 163. And you're going to multiply that by 68 over 162. And somebody give me 4 digits on that.
176.
176 is 3. What's the 4th digit? 1760?
1776.
1776. That's in bicentennial year. Thing over 1776. Thing over Declaration of Independence. Alright? So that should be 0.7178. So would you put money on it? I wouldn't. Because you win a lot of money on it. Yeah, because the probability is only 0.18. So you could win a lot of money. I don't know why you can, But anyway, this probability, what I'm saying, that low probability would give you a high payoff if you were in Vegas or whatever. So we need to punch 178 so we can feel good about ourselves. And you do. So you don't have to wear sunglasses inside the building. Is such an event unlikely? Well, yeah, 0.17, I would say it's unlikely. But they're wanting you to check with the 5% rule. So, trying to see how you would do that. If two different drivers,
So it would be no because it's greater than 0.05.
yeah, because it's 18%. So it'd be no because it's greater than, yeah. Thank you. All right. This is a good test question. I don't like these. I never have liked them. There's a dang alarm clock question somewhere. Find that alarm clock question. I like to use it. I have 2 alarm clocks in my bedroom. 3 with my phone. All right. The principle of redundancy is used when system reliability is improved through redundant or backup components. Assume that a student's alarm clock has a 17.5% daily failure rate. Complete parts A through D. And I can't go through A through D, so we'll just do them part by part. So write it down. So what's the failure rate? Point what? Should be 0.175. Says assume that a student's alarm clock has a 1 point or failure rate. So that means that what is the probability of a student will not work? It's 0.175. 0.175. Well, if you miss that, don't tell anybody. Okay? B, if the student has 2 such alarm clocks, what is the probability that they both fail on the morning of an important final exam? Both. Dang old both is word for what? 2?
So 0.03.
Well, you take 0.175 and raise it to the what? Yep. 0.175 raised to the second power. I better write that down for the people at home. You're allowed to miss this one, okay? Not this one. You're not allowed to miss that one. 0.175. Y'all laugh at anything at all? Y'all talk about anything at all? Raised to the second power. Well, no. I think I'd take them back and use cell phone. But my daggone power goes out, and I look up, my daggone phones is sitting on my headboard, that dang old blinking. So if it wasn't for my cell phone, I would be in trouble. So what does that come out to be? 0.0306. What? Oh, I'm sorry, I wasn't paying attention. 0.0306. 5?
No, 3.
Why don't y'all just like setting me up, don't you? Let's start over. Point.
0.0306.
Thank you. And what's the next one? Just in case.
5.
5. Okay, so dang old 0.03064.
No, but 3. It was a 2 there before the 5, but we told you that.
I asked y'all to tell me the numbers, and y'all will not do it. Y'all
told
just
us to round.
okay. Well, y'all give me 6 digits.
Okay.
Okay, I don't want y'all to do anything but give me 6 digits.
0.03065.
Okay. Now let me do my own rounding. Okay. They go to talk when you do talk. Give me the wrong answer. All right. 0.03063. Is that sufficient? All right, so you got a 3% chance that the 2 alarm clocks is what? They're going to fail. And that 3% chance is probably going to be dang old the same as the power going out for a second or two, knock them both off. So that's what you would put there. Now let's see what else they're going to ask. And the reason I picked the alarm clock because it has everything in it. 0.03063, and we feel good about ourselves. What is the probability of not being awakened if the student uses 3 independent alarm clocks? Well, technically you could say, I don't know, there's not enough information. But they're assuming that you're going to buy another what? Alarm clock like this one. Okay? Technically somebody can go, well, the question doesn't say what kind of alarm clock you're going to buy. If it's going to be like the first one, or is it going to be... Shut up! All right? Just raise it to the what power? Third power. All right, so that would be... I'll just write it. So that's going to be 0.175 raised to the third power. Give me 6 digits, please.
All right, you ready?
Yeah.
0, 0, 5, 3, 5, 9.
So that gives us 0.00536. Now, technically, you could write the 0.01. I think I would, at this point, email the company of the 3 alarm clocks and say, y'all suck. Okay? Because I got a 1% chance of not being what? Woken up with 3 alarm clocks. I think that's pretty bad. Okay? They probably send you a brand new alarm clock that is super accurate. 0.00536. Okay, stupid question time. Do the second and third alarm results greatly improve the liability? Well, it's more than 5%, I would say. Well, I don't know if it's more. No, it's not more than 5%. It's only 3%. So what would you say if it's not greater than 5%? No. Yeah, this one. Because this one, no, because total malfunction, total malfunction would be all 3 of them not working. And I don't think that's possible, so I'd say it would be. Nope, got it wrong. Watch it be C. Correct answer, C. Yes, because total malfunction would not be impossible, but it would be unlikely. Okay? If you can figure that out, tell me. Tell me what that means, all right? Gosh, no wonder we gave this book up. All right, so I'm not going to hold you too much to that last one, okay? But it says yes, because the total malfunction would not be impossible, but it would be unlikely. Okay. Saying it wouldn't be. Yeah. It would be unlikely. That's what they're saying. Do the second and third alarm. I'm trying to understand what they're saying. Do the second and third alarm clocks result in greatly improved reliability? I don't think so, because what's the difference between 0.03 and 0.00? 3%. It's not greater than 5%, so I disagree with that. I would say no. I think it's improperly worded several different ways.
They're asking if the second and third alarm clock is the addition of either or
Yeah.
from the first.
I just don't think it's a good question. Well, this part isn't. And I think you're good up to C. So I'll be very lenient on this. So what does that mean, Hubert? That means after this test, if you get this problem wrong, D, I'll be very lenient and I'll probably give you the points. But you got to see me and I got to fix it for you after class or something like that. Okay? All right. Now let's look. I'll tell you what, it's 1:45. Yeah, I got time. Let's go ahead and look at the test. And let me go ahead and load the test so I can. Now remember, 4.5, this test, and I'll do this for the, let me write this down for the, this test will cover, it'll be on your test as Form A, it'll say unit, what is it, Unit 2? Unit 2, Form A. I don't know if it's called Form A
Yeah.
or if it says Chapter 4. What does it say?
Form A.
Form A? Okay. This covers 4.2, 4.3, 4.4, and 4 point what? What did I tell you we skipped in this section?
4.5.
Skip 4.5. And if the people at home watch the videos, they probably will see that it was skipping 4.5.
So we just not doing that homework?
Yeah, and if you did it, I'm sorry, you went ahead, I'm sorry. I mean, it's not gonna hurt you. You just did some extra work, okay? Now, if you want me to put the 4.5 material on the test, I will. Okay. All right, that takes care of those questions. All right. Now, Form B, let me go ahead and tell you what Form B will cover. Form B will cover Chapter 5 material. Let me write that down for the video, for the online students. Unit 2, Form B, will cover Chapter 5 material. I don't know what it'll cover yet because I haven't done it yet. Chapter 5 material. Whatever's on the syllabus, somebody tell me what the syllabus is. I think there's 3 sections that we cover in there. Just go to the last page that y'all should have on your notebook. What? Yeah. 4, 2, 3, and 4. 5, 2, 3, and 4. 5.2, 5.3, and 5.4. You're talking next week, probably. Okay?
So 4.2 through 6 has to be done tonight, right?
Well, I'm fixing to do that right now. So we'll see. As far as the in class, let's see. Let me go to the handy dandy book. There we go. Is it already posted? I've already got it posted.
Yeah, you
Good. I ain't got a copy of it. Okay. Let me go to the assignments. I'll make sure I got the questions. Make sure that there ain't no 4.5 on there. Or 4, is it 4.5? Y'all are 12012. There is Unit A. Let me go in and check it. Point 2, full way. 4.3, 4.4, 4.6, and I should have 13, huh? Oh my God, well let me take that off because somebody will have a conniption. Oh my God, they'll go into hammy, which, what happens if I put a question on your test and it's from 4.5, do you think I'm going to make that hurt y'all? No, I'll fix everybody's test after it's turned in. I'll fix everybody's test and everybody will get 5 points or whatever. I'm not that kind of teacher, okay? So hopefully y'all have figured that out by now. But, I mean, people at home too. Let me count these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that's it. How many questions are on the test besides the 13? Gives you 10 questions. That should be pretty simple. All right, save and assign. Should have hit next. Oh well. So we'll put copy Unit 2 test. Let's go ahead and let me just go up here, change dates. And this is the Unit 2A. And today is the 11th of June. I'm just starting at 8 o'clock today because that way everybody will see it. And if I start it tomorrow, then I'll get a hammy call me tonight and say, it's not posted, it's not posted. Well, that's why I put it at 8 o'clock this morning, so it will post. And the 11th is June 11th. June 11th, so we'll make it 18th. Okay, is that self-explanatory? All right, let's go over to the homework. Let me go right quick and make fun of people who haven't done the homework so I can see how many people I'm going to have to fuss about. Okay, let me go back here. There we go. Let's look at the homework for chapter 4. Okay, go. There we go. And I'll take the 4.5 off. Don't worry about that. Oh yeah, y'all look like y'all really busy. If I set it for midnight tonight, there's going to be some hurting people. I should.
Don't be mean.
There's only 3 people in here that should be telling me not be mean, and that's the 3 people that are working on it. Oh, I did the first 2. Be quiet. You're not who I'm talking about. I'm talking about these people that are actually, I don't know who they are, but they're actually working on all the sections. I'm not too happy right now. But anyway, and then guess what? Y'all going to have 15 questions next class because you're actually doing the homework. So I'm not too happy right now. Chapter 4. .2, 4.3, 4.4. Y'all know not to say anything right now. I better not hear any complaints, because I should cut it off tonight. All right, so now when you go to homework and you click on homework, it'll say, we're not ready to go yet. It'll say on chapter 4, it'll say what? 6:15. So you need to look on your calendar and see when 6:15 is. When you go to test, it'll say that your unit 1, 2 copy A is what? Due on the 18th. So now you are ready to take that test and do that homework. Should have already done the homework. But anyway, let's look at the test just so you can see the format. Assume one individual. Okay, here we go. Given that he or she had the what? What does he or she mean? Additive rule. So he or she had the blah, blah, blah test. So find the probability of someone whose test is positive given that he or she had the disease. Individual had the disease. Okay? So there's your had the disease. So it looks like to me that's, didn't we do a question where it was everything and it was 100%? This looks like that type question. All right?
No, it's because they didn't have it.
Given he or she had the disease. Okay, had the disease. So that'd be 137 and 19. And it says, find the probability against someone who's tested positive. Okay, so it'd be 137. Yeah, it'd be 137 over what? What's the total added up? That's all they're asking. So that he or she, they should put a slash there, not put or. They should put a slash there because that's confusing to people. So 137 over 300. Y'all can do that on your calculator.
0.45.
What does it say? Point what? Next question. And of course, when's the week of finals? I don't get these questions anymore. Wonder why.
Records.
What does grade book do? I like to predict temperature for July 4th. You know, grade book, temperature prediction. Don't that match? Grade book, temperature prediction. You know, grade book, what would that mean? Is that our grade for the semester? Nope. It's your IQ. All right, we did this one. Remember doing this one?
Yeah.
That's why I told you to remember this one. I think it's 1/8, 3/8, and 3/8 or something like that. Exactly 3 boys. Well, 3 boys would be 1/8. So you type in 1/8. Exactly 2 boys. That's 3/8, isn't it? Exactly 1 girl, that comes out to be 3/8. If I can ever get down there. Next question. Each of the 2 parents has a genotype blue-green, which consists of their pair of alleles that determine eye color, and each parent contributes one of those alleles to a child. Assume that if a child has at least 1 blue allele, that color will dominate the child's eye color will be blue. List the different outcomes. Assume that these outcomes are equally likely. Well, I don't know which one it is, but let's think. How many children? 2 parents. Each of 2 parents has a genotype. Okay, so the child could come out blue-blue, blue-green, green-green, green-blue. So that would be D. Probability that the child's green-green would be 1/4, 0.25. And the probability that the child will have blue eyes is what? 0.75, whatever you say. I'm going to the next problem. I'm looking up here and trying to do everything at the same time. All right, next. Why does Hubert not entertain extra points, extra grades, or dropping any grades during the last week of the semester? A, I thought it was because I don't like you. No, because he wants you to fail and live in the ditch. That's what I like. Next question. Which branch? Next question. In genetics experiment on peas, 1 sample of an offspring contained 412 green peas and 492 yellow peas. Based on this result, estimate the probability of getting an offspring pea that is green. So that'd be 412 over 904. Somebody help me out. What's 412 over 904?
0.4557.
And it says round to 3, so 0.456. Well, that ain't 75%. Is this probability close to 75%? I'll probably get it wrong. Next question. What is the last day of the semester? Use the following results for the potheads. This is a pothead question. I can't stand these questions. Use the following results from a test for marijuana use, which provided by a certain drug company, testing company, or whatever. Among 150 subjects with positive test results, there are 20. Okay, this is where you have to make a what? Make a chart. So go ahead and make one. Make it. Okay, you got 150 with positive test results. There are 20 with false positive. So let's take our handy dandy whiteboard. All right, what we gonna call what?
Um,
150 subjects with positive test results. There are 20 false positives.
So just do positive, like really positive.
Okay, so positive right here. We'll put positive test results. How about that? Positive test results. Didn't type. I don't know why it's not typing. Thank you. Positive test. We'll just say positive test. And what's the other one going to be called? Negative test. And what's the other categories before we start doing the numbers, huh? Okay, we got accurate. Hold on. I'm getting there. We're supposed to be getting new boards, believe it or not, by next semester. And they're the boards that don't have a board. They're just, the projector picks up on your motion. Just weird. All right, and you say accurate and inaccurate. I don't know how to spell, so if it's not right, I hate it. I don't need a English lesson. All right, so positive test results and 150 with positive results. So 20 false positive, 156. So you got 4 numbers up here. Where do they go? What goes in this first box right here? Say again? 150. It should be this. Among 150, yeah, this is the total. Positive test results is 150, so it should be false positive result. That's inaccurate, right? So that would be 20, and this would be what? 130. So you got to be careful because it'll bite you if you don't watch it. Let's see. I'm trying to work where y'all can see it, so y'all just have to bear with me. 130. And 20. And then the other is 156, but it'll be 152 and 4. So that'd be, make sure I put them in the right place. 152 and 4. It's like working with a piece of barbed wire. Some of y'all don't even know what barbed wire is, but anyway. All right, so now what are they asking? They're going to ask, what is the probability of a false positive or a false what? Well, what is a false positive? That's inaccurate, right? So we highlight what? False what? So where is false positive? Inaccurate. What else? False negative. Which one's false negative? The what? The 4. And it says false positive or false negative. So that's going to be 20 over what? 20. Oh, what we got to do? We got to do 20 plus what? Or 20, is this? I'm looking to see if it's over. Yeah. It's additive law. What does it come out to be? 24 over, what did y'all add it up? 306? Whatever it comes out to be. 24 over 306. I can't write right now. 24 over 306. And what does it come out to be? 0.078. And we put that in the 0.078. What does the results about the test accuracy? We're 5%. It's above 5%. So that means it's not what? It's not accurate. So you need to find the thing is higher than 5%, or you know it's not highly accurate. So does not, it's not that one, it's not that one. So it says with an error rate of 7.8, that's it, B. Because it's not that. And that's your answer there. Next question. All right, here's the question we just did. All right, this one says, given that 2 of the 25 subjects are randomly, okay, A and B. All right, it says, assume that the selections are made with replacement. With replacement. What is the probability that the 2 selected subjects are both group O and RH positive? So it says and, so that means what? It means multiplicative law, right? And it's talking about RH positive, which is this number. You got to add those numbers up. And then O is this number. So 89, that's what, 100? That's 100 right there, isn't it? So, you know, one of them is going to be 100. Does it say without replacement? Or it says with replacement? With replacement. So it's not going to change, so you don't have to worry about subtracting. So 100 over, is it 225? Is the whole thing 225? Times what? What's the RH? Y'all with me or what?
Why did you put 100?
That's 81 plus 19. That's the,
But wouldn't it be because if they're both O and RH?
it says, what is the probability? Oh, both. I'm sorry. You're right, both. I was thinking and. Okay.
So it would just be 81.
Yeah, you're right. I was reading if it was O and RH. That's what I was reading. Okay, so that would be 81 over what?
225. That's what it says on
225, yeah. 81 over 225 times what?
81 over 225.
Because it's 2, right? Given that 2, so that'd be raised to the what? Second power. And crank that out for me. 0.1296. And that's what would go here, 0.1296. I was thinking of a different problem. 0.1296. Assume the selections are made without replacement. 81 over 225 times 80 over 224. So let me write that down. 81, and I'll forget it. I'll just write it. I can't write with a mouse. I don't know if y'all ever tried to write with a mouse. It's not very easy. It's very difficult. So this one would be 81 over 225 times 80 over... Let me ask y'all a question before we answer it. Is it going to be different from 0.1296? Yes. Well, it should be different because you only got a 2-digit number right there. So what is it?
It is 0.12857.
That's a big difference because these 2 digits are really different from these 2. Now that was 1.295 or 1.297, then I'd say they're fairly close. But the reason this is different from this one is because you got a 2-digit number in there, and that makes a difference. Yes, sir.
You know if this data is actually accurate?
I don't know. They pull it. They show you in the book. You have to read in the book where they get it. They get this data from other places. Huh? Yeah. I think, now some of these are regenerated. So they just regenerate. In other words, they just throw numbers in there. So, I don't know. It probably comes from one problem that they actually took from the data, and it just regenerates. So this is 0.1285. What do I do with the grades? Takes the highest. Email address. C. It's not supposed to do this. It's supposed to spread them around. Is it online? There's our roulette question. Go ahead and answer it. This is the one that I told you that one of them was the same number. And don't miss it. That's C, right? So, the roulette table is 36, has 36, so that means it has 34 numbers. So that means the probability, we've got to see which one's a success. Even. Even is our success. And our failure is the probability of what? Not even. Remember I told you, do not use that word odd, so it'll get you in trouble. Even is what? 17 over what? 36. And then, what's this number? 19 over 36. Now make sure you keep everything as a fraction, so it'll make the working it a whole lot easier. So what's the probability of winning? 17 over 36. All right, the odds against. Odds against is the probability of failure over the probability of what? Success, Hubert. That's right, class. So the probability of failure over the probability of success is equal to 19 over 36 divided by what? 17 over 36. And what happens to the 36s? They cancel and you have 19 to what? 19 to 17. Now what did I tell you to do for C? Put the same answer. Don't even look at it, just put the same answer. So, how much money would that be? So what's this answer? 19. Don't even do that. Don't even think about it. All right, now this one. This one is going to be $19 times 19 over 17. That's your conversion factor. And what is your answer? Somebody tell me what the answer is. 21 something or 20.
21.235.
$21.24. Now remember, I told everybody that when you type the answer in, don't think about the profit. Change that to payoff. The payoff, the horse race people are going to pay you off how much? $21.24. So $21.24 goes here. If you think of profit, what are you going to put down? You're going to put $2.24. You're going to get it wrong. Okay? So let's type those answers in. $17 over 36. $19 over 17. Or what did I say? 19 over 17. That is 19. And 21.24. Next question. Should be. Should turn it off tonight. What does Hubert replace your lowest test grade? No. What is grade book? I'd say coconut. Grade book, coconut. Grade book, water lily. Grade book, contempt. Grade book, final grade. Golly, reckon which one matches? That's the most asked question. Is that grade book? What does that tell? Does that tell us what we're making or nope. It tells you your IQ. There's your lottery question. Find the probability of winning the lottery with the following rule. Select 5 winning numbers, any order. Now what is it saying? What's that word mean? That means you bought a ticket. So it'd be 1 over, and somebody do the combination of 32, combination 5 for me.
You just divide them?
No, I want to know the number, the denominator. What's the denominator? What's the 32 combination 5?
2, 0, 1, 3, 7, 6.
1376?
How'd
Yep.
you get that?
32 combination 5. 32 math probability. What number is it, y'all? 4?
No, it's 3.
3? And then 5. Type in 5, and then that should give you. Did everybody get 201,376? Let me check it. Y'all ain't gonna tell me either way. So 32 math probability combination 5 201,376. And next question. All right, check that one. The table below summarizes results of people who refuse to answer surveys. A pharmaceutical company is interested in opinions of the elderly. What is the probability that the selected subject is someone 60 and over who responded? 60 and over who responded. So 206 over whatever number that is. So somebody tell me what 206 over, what's the denominator?
Why wouldn't it just be 60?
60 and over.
Instead of the
It would be a lot. It's just,
Be 206. I'm just saying 206. It'd just be 206 over what? The denominator. It's going to be a BA denominator, isn't it?
It's going to be 10, 10.
Okay, thank you. So 206, well, I got to give me 3 decimal places. Be 206 over, what'd you say it was? 1071. Hold on a second. Let's say 0.2 something.
It's 0.19.
2, 3,
Okay.
4,
0.19 what?
2, 3,
0.192. Is that good? Next question. Where is all of Hubert's homework and tests done? In the bathroom. Okay. And the last question, I think. Oh, the CDs. All right. A fan of country music plans to make a custom CD with 26 combination 14. 26 combination 14. That's going to be a BA number. What is it?
96, 57.
96, 57.
70.
70? So is that good?
No, another 0.
Is that good?
Yep.
So are you going to walk around with almost 1 million CDs in your...
I said 57, 70.
I tell you, y'all just give me a hard time. 57, 70.
Yeah. Oh, that one.
I'm taking them off. How about that?
No,
No,
more
another
zero.
0.
You got to pay attention.
5770. That's what y'all call 5770.
Yeah, 57.
She said 5770 and there were other zeros.
Yeah,
And I'm supposed to translate that. Okay. So, are you going to walk around with 9 million CDs in your pocket?
but
No. So it's not practical. Very large. So I'd say D. And then you submit test. Uh-oh. We made an 89. I didn't think number 1 was right to begin with. We got this one wrong. The 5770 or .192. Y'all need to check that one. What did we do wrong?
It might be that.
I thought it was 206, but y'all check it. It might be 206 plus 57. I don't think that's right either. What is the probability that the selected subject is someone 60 and over who responded? It should be 206 over the...
It's 1255 on the bottom. You have the wrong denominator.
I'm not going to ask y'all for no more input.
So it would have been 164.
So we did the mechanics right. Y'all just gave me the wrong numbers.
Yeah.
Thank y'all. Oh, that's good. I'll give y'all credit on that. I'm not going to worry about that. That number 1 bothered me, though. 4, 5, 6. I didn't think that was right. I didn't think that problem was right to begin with. It says, assume one individual from the group is randomly selected. So that means we're just going to find one person. Find the probability of getting someone who tests positive given he or she had, I don't like that word right there. I think we did too. Somebody can't add. How much is it? That's 270. So it'd be 290, 301 minus 1, 300. I don't know. I'm just doing
that
the
was
math.
our denominator.
What was it?
That was 300.
Well, what did we put in? Take 137 and divide by 300.
And you get 0.456.
So we didn't do it right.
So
Nope. I think it should be, let's see. Find the probability of getting someone who tests positive given that he or she had the disease. I bet it's 149. Try 149 over 300. No. Yeah, 148 over 300. That wouldn't be it. I'll have to check on this one. Don't take the test
that
till...
thing is not right.
Yeah, we'll check on this one.
Try the additive.
The additive, it would be test positive. Try that.
The only way
Test, wait a minute, try that.
wrong too.
What's 148? 148 and
It's 0.493.
had the
The only one
disease.
that's anywhere close to that number is if you add 137 and 133 and divide that by 300.
Okay, well, I'll check on this one. Y'all take the test Monday. We'll work on it Tuesday. How about that? All right, y'all get out of here. Have a good day.